Okay, we're gonna start this session by talking about the material conditional. I screwed up the recording last time, and that's pretty much why that's one of the reasons why we are doing a rewind. So, Patrick, I'll let you do the rewind, and we can move from there.
Right, so the material biconditional, it's the fifth binary operator which we have covered so far, and it works with two variables either side. That's why it's got called binary, also known as the if operator. It's represented by an arrow going to the left and to the right, or the other symbols that we can see. And in the truth table, the operator has a truth value when both of the variables have the same truth value. So when they're both true, it's true. When they're both false, it's true. So it's basically representing that it's true when P is implied, P and Q are the same.
P and Q are the same, and yeah, they have the same truth value. Yeah.
Yeah.
Okay.
So after that, we did a proof here. So we proved that when P and Q, yeah, so when P implies Q and Q implies P, it's the same as the binary, the
Biconditional.
biconditional material biconditional, yeah. So
Yeah.
the best way to do this is how you're doing maths. So you do what's in the brackets.
Yep.
So you first write out the different variables we have. So we have P and Q, and
Yep.
then we work out what P implies Q is, what Q implies P is,
Yep.
and then after we put it all together, and then we find that this proof is the same as the biconditional.
Yes. Right. So that was a biconditional, and basically the natural language motifs are going to be what?
So if and only if.
So how would you
Uh,
use that in a sentence? Like, let's say
so
you have two propositions. Bob is a goat and Joe is a dog, and you want to and both of those propositionals are like connected by the by a biconditional. So how would you say that out in natural language?
so what was the first one? Bob is a goat,
Yeah.
right?
Yeah.
Is a necessary and sufficient condition for, what was the second one you said?
Joe is a dog.
For, yeah, so Bob is a goat is a necessary and sufficient condition for Joe is a dog. Yeah, that's the last natural language motive we have there in the bullet point list. The first one, if and only if. So Bob Bob is a goat if and only if Joe is a dog.
Yeah. Yeah. Uh, Joe is a dog. Yeah, Bob is a goat if and only if Joe is a dog. And same thing. All of the each of them can be um, swapped around. And we talked about this mnemonic, right? We talked about like sun. So the antecedent is always a sufficient condition, and the consequent is the necessary condition in a conditional in a material conditional, and like this is going to be like P double implies Q would just mean the same thing as the conjunction of P implies Q and Q implies P. Okay, we can move to the next part. So basically that was like the rundown of material biconditional, which is pretty simple, not very complicated.
So just to be clear,
Yeah.
the this biconditional, it means that they're not the same, that they just have the same truth value.
Yeah, they have the same truth value. Both of the propositions have the same truth value.
Yeah, and yeah, the arrow which was the conditional in the proof. It
Mm-hmm.
can also be uh, called an implication, right?
Yeah.
Okay, yeah, because I don't think we wrote down the word implication anywhere earlier, but
Yeah,
just
you.
so
I mean,
people
yeah,
are.
like that's one thing. It can be called an implication too. But I generally don't call it an implication because there is a rule of replacement called material implication. Um, so I don't want you to get confused between this and that. That's why I avoided using the term implication so far. But yeah, you're right. I can say P implies Q. That's the same thing as if P then Q.
Mm,
Yeah, and the symbol is an implication symbol. That's right. But yeah, like I didn't mention it so far because of the there is a rule of replacement which we will cover in the down the road when we do rules of replacement. So yeah, I just didn't want to put that out like prematurely. That's why. Yeah.
okay, and so where we have material conditional, that can also be in well, as a dash, or we can also call it an implication.
Yeah.
That would be correct. Okay.
Yeah. That would be correct. Yeah. Okay.
Right, so yeah, we didn't cover all the natural language motifs there for the biconditional. We covered the first and the last one in the list, so just so people have yeah,
Yeah.
when and only when. So Bob is a goat when and only when Joe is a dog,
Mm.
and yeah, Bob is a goat just in case Joe is a dog,
Yep.
and then Bob is a goat uh, is a necessary and sufficient condition for Joe is a dog, which we already said. Yeah.
Yeah. Yeah. That should be fairly easy now. Okay,
Yeah, and
so then we went on to. You wanted to say something?
so you last well in the lesson which didn't get recorded,
Yeah.
you gave me a few examples. Do you think we should first do those or talk about the converting text into or converting natural language into symbols? What do you think
Oh,
is better?
let's finish this the recap and then we can go to that and then we can go to syntax.
Cool.
Yeah.
So yeah, what we were doing here, we had a few examples of what natural language, and we were trying to convert it into text. Well, not into text, into symbol form, using variables and operators.
Mm-hmm.
And so the first one we saw was I met Sean, comma, a clown and an acrobat, and then the second example we had was I met Sean, comma, a clown, comma, and an acrobat. And so for the first example, so these are two separate examples of how we could convert them into variables and operators. Um, so I met Sean can be represented by a S for
Mm-hmm.
yeah for the first bit. Sean is a clown can be represented by a C,
Mm-hmm.
and then Sean is an acrobat represented by an A, and so what we could do is say that for the first one is that you met Sean. Sean is a clown, and then Sean is an acrobat. So you can connect them using using an and operator, which is a conjunction.
Mm-hmm.
So we have two conjunctions there between this S and the C, and this C and the A.
Yeah. So I mean, the important bit is that both of them are in the form of like are in the form of three propositions which are tied with a conjunction, right? But the difference here is that uh, in one case you are talking about meeting three different people, and in the other case you are only talking about one person, and the rest of the other propositions are descriptions of that one person that you met.
Yeah.
So even though the symbolic form is the same, uh, the natural language varies. Like the actual propositions that you're trying to represent are different. And more importantly, like for instance, when we are talking in English, we don't talk with commas and periods and all of that, right? Like when I met Sean, a clown and an acrobat. If I say that, you like it's not very clear what I mean. Do I mean the first statement or do I mean the second statement? Because if I mean this first statement, but you interpret it as the second statement, that's gonna be a problem because I haven't been explicit about whether I met one person or whether I met three people. So uh, it's important when we are doing translations from natural language to formal symbolic language, it's important to get the meaning of what the other person wants to convey, like very clearly. And that was like the important bit of this section.
Yeah. So yeah, when I was
Yeah.
describing it, I only described what I did for one, but yeah, you explained exactly the difference between one and two, which is good. So
Yeah.
yeah, people should. I'd recommend people listening to stop and try that exercise just so, because if we're going a bit fast, so people can understand for themselves.
Yeah.
Yeah,
Okay.
and so what we then did after that was you stated that we could also have a disjunction, an exclusive or an inclusive disjunction
Mm-hmm.
for the you may have salads or potatoes and carrots. So it's not very clear in natural language whether we have an inclusive or an exclusive disjunction, but normally people, what we assume when, well, normally when people use an or in natural language, they're probably talking about an exclusive disjunction.
Yeah. But yeah, like it also depends on the context. Like if you're in a like if you go to a wedding, nobody's gonna stop you from eating both salads, potatoes, and carrots. You know.
Yeah.
Uh, so yeah, like it really depends on the context, on what the person means, and all of that stuff when we are trying to figure this out. So yeah, like the important point is that like there is this one sentence, and there are four different propositions which can be expressed with the same sentence, right? Um, and to disambiguate which sentence it is, we are going to need like more information, like what's the um, author intending to say, what's the context, etc. So that's like yeah, that's why we need to we need to try to make our language as unambiguous as possible, as unequivocal as possible.
Yeah.
Okay, yeah. So the next um, section.
So just to say, people should also try that example with the salad, just so they can understand.
Yeah,
I would recommend them to try.
yeah. Like I don't see any like fact of the matter apart from the author's intention, which will tell me which of these interpretations is the correct interpretation. Um, maybe yeah, like maybe some context can provide you with like a reasonable guess, but like with like the only way you're going to confirm what the author intends to say is by getting their intention explicitly.
Mm. And to
Okay.
recap, the V with the underscores either side, that's an exclusive disjunction.
Right.
So yeah, so for example, yeah, number one is yeah, you, you may have salad or um, potatoes and carrots together. So you either have one or the other, which is probably at a wedding not what people are implying when
Yeah.
they're asking.
This
When
is
they're telling you.
probably so. Case one will be probably something like a I don't know, like a school, like some kind of food served at a school to kids. Like you don't get both. You don't get salad and potatoes and carrots. I'll either give you salad or I'll give you potatoes and carrots. So you only get a plate of salad or you get a plate of potatoes and carrots. So that's the interpretation for the first one. Okay. Yeah. So what's the second one?
So the second interpretation is that we have a yeah. So you may have salad or potatoes, and we have one or the other
Mm-hmm.
with carrots. So we've got a conjunction there. So in the
Yeah.
brackets, it's saying that you can have one or the other. You've got a choice there, and then you can have the carrots with whatever you choose out of the salad or potatoes.
Right. So, like in this interpretation, the carrot is basically guaranteed. Like you are going to get carrots, but you have a choice between what you want to pair carrots with. You can either pair carrots with potatoes, or you can pair carrots with salad, but not both.
And then number three is similar, except the salad is what is so you have the salad, and then you have all the potatoes and carrots. So in this one, it seems like the salad is guaranteed, right? Is
Oh,
that correct?
at least one. So either not really, not only the salad. So it could be either the salad is guaranteed or the other one is guaranteed.
Yeah. So yeah, you may have salad. Then we've got or
Yeah, at least one is
potatoes.
guaranteed.
Yeah. 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 Good to cover that. And then number four is you may have salad or potatoes. So one of the other. It's a so this one is an inclusive
Yeah,
disjunction. So you could have both of them,
yeah.
and
Again, so
then
here in this case again the carrots are basically guaranteed, but you can choose whether
yeah,
you want to take salads or potatoes with it, or you can take both.
yeah.
Yeah.
All right, great. Then we can move on.
Yep. So then we go on to representing arguments in symbolic form. Yeah. Go ahead.
So that's just how you tend to, yeah, the general form for an argument. So we have P implies Q, Q implies R,
Mm-hmm.
right? And then for the third proposition, we have. Could you explain what we have there going on in the third proposition?
Oh yeah, one sec. We just skipped the natural language, right? So you have some argument, right? And then you
Yeah.
have premise one, something in written in natural language. Premise two, written something in natural language, and then you have some more. Maybe you have more than two premises. Sometimes you have five premises. Okay, and then whatever number of premises you have, after that you end with the conclusion, and the conclusion you begin with therefore, and then you write whatever the conclusion is. So that's generally how we express a an argument in natural language. And symbolically what we do is, so this is premise 1, premise 2, premise 3, and then the slash represents the conclusion. Like instead of writing c dot r, we just put a slash and we write the conclusion at the end of the at the end of the last proposition, last premise.
hmm So
So
do an example?
yeah, this is the example. So so when you're writing in natural language, p1, p2,
Yeah.
p3, whatever, and then you write conclusion and then you write this, so that will be like a natural language representation. And in symbolic form, this will be the representation. Basically, this I have represented like 1 2 3. 3 will be p, 1 will be p implies q, 2 q implies r, p therefore. So this slash represents this therefore and r. So this is the conclusion.
Okay, that's what I was here getting a bit stuck with because I wasn't sure what the slash was doing.
Yeah. So these
What
are
is that?
the premises, and this is the conclusion. Okay.
And because I know you can also represent therefore with three dots. So is
Yes, you
that the
can.
same as is that the same as a slash?
Uh, it is, but only, but like you use a therefore when you are using like a hybrid representation. Um, when you're only using symbols, the convention is to use a slash.
Okay, got it. And currently, our definition for our working definition for an argument is a set of propositions such that at least one proposition is a premise and at least one is a conclusion.
Yep.
And a conclusion is also a proposition, right?
Yes.
Yeah.
Has to be.
All right. So then, is there anything more which we did? Or I think that's it.
I
Right?
think that's it. Yeah, I think that's it. Okay.
So maybe just what were the three horizontal bars there at the top which you had in?
One sec. What was that?
So if you go up a little bit, yeah. So where?
Oh,
Yeah,
this just means equivalent, like logically equivalent.
okay.
Like logically equivalent.
So that they just have the same truth value.
Yeah. They have the same truth table. Like, for example, this, like, this and this will have the same truth table. So these two are logically equivalent.
Mm-hmm.
Okay. Yeah. So, yeah, I guess we can. Oh, now what we can do is we can go to the stuff I sent you and then we can solve that. I think you've already
Okay.
solved it, so I'll just.
Yeah, I'll just share my screen.
Yeah. Let me move my. Yeah, share your screen. I'll change the window. One sec. Yep.
Can you see my screen?
Yes.
Alright, so yeah, material biconditional.
Okay.
So last lesson we did one of the proofs together,
Yeah.
and then you sent me another one of the proofs to do. You sent me that Q implies P and P implies Q. So this one here. So what I assume we would do is we would write out the truth table for P and Q. So just same as it always is. So both start off with true, and then you make one a false, then you make the P a false, and then you make them both false. And then, so for the implication, we have TTFT, and then for the P implies Q, we have TFTT. And we get the same as for the material biconditional.
Yeah.
Yeah, you happy with that?
Yeah, that's fine.
And then so this was the question you gave us to do. So P implies Q, disjunction. So P implies Q, or P and not Q.
Yeah.
So what I did was, same again, you've got P and Q's. I'm going to assume that people listening now, they just know how to draw out the truth table for the first two columns. I'm not going to be saying this every time, I guess, because we're going to be doing a lot. So just the two columns for P and Q, and then not Q, you just, what's true, or the truth value of the Q in this column, you just make it negative. So, well, you just do the opposite truth value. That's what I mean. And then after that, you've got P implies Q.
Yep.
So, yeah.
Is that right?
No, there's a mistake there, I think.
Yeah.
So I think I think I corrected the column there.
Okay. Yeah.
Yeah, that was a mistake there because it's P implies Q is true when Q is true, it's always going to be true.
Mm-hmm.
So that's why there's a that needed to be corrected.
Okay.
And then the two falses is true. When P is true and Q is false, that's a false.
Yeah.
And then when they're both true, that's a true. And then after that we have P and not Q.
Mm-hmm.
So you want them to both have the. So when you've got a conjunction, you want them to both have both be true,
Yep.
right? So then this one is false because P is true, not Q is false.
Mm-hmm.
Then this one is true, false, and then because P and not Q, because P is false and not Q is true,
Mm-hmm.
then it's false. And then so I'll just probably need to correct this one because I had to correct the other column.
Yep.
So when it's or, we got exclusive disjunction here.
Yep.
We want only one of them to be true. So what we do is we want to look at the last two columns and then just check when only one of them is true. So this one is true. This one now needs to be true.
Mm-hmm.
This one also needs to be true.
Yep.
And then this one is also true.
Yeah.
Does that sound right, what I've done, or is there any mistakes?
Yeah. I mean, yeah, whatever there were, you corrected them on your own, so that's fine.
Alright.
So what I'd suggest you to do is draw another table, but this time draw the table for P and not P. So just make the first two columns just identical. Like first three columns are identical. Or sorry, first two columns are identical. Well, you don't even need first two columns. Just the first column, and then you just need a second negation column. Yeah, P and not P.
For P and not P.
Yeah.
Are we still doing the same question now?
No, no, no. Just a different question, but just P and not P.
Okay. Okay.
Okay, you're gonna need another column
So you want another column, yeah?
for P and not P.
Can you see my screen?
Yep. Okay.
I've got a column for P, I've got a column for not P.
Yeah.
You said you wanted another column or not?
Yeah, for P and not P. P conjunction not P.
Okay. Yeah.
Yeah, that's fine.
Right?
Yeah, that's fine.
So then I can just copy. So yeah, I guess it's just like that, right?
No.
Where,
How do you
so
write?
when P is true, not P is false, right?
Mm-hmm.
And then so when P is false
Yeah.
and not P is true,
Right. Well, you don't need the other columns. Yeah, sorry,
Yeah.
the other rows. Yeah.
yeah. So then, yeah. So we want them to. So both of these are false,
Yeah,
right?
yeah. So the reason I asked you to do this particular one and the previous one is to show you. Okay, just copy paste this in the latest table and erase the third column. Erase in the sense you need to replace it with something else.
So you want me to copy and paste this whole table?
Yeah, the entire thing. Yeah.
And then
Just change the third column to P disjunction, like a inclusive disjunction, not P.
so P inclusive disjunction, right?
Yeah, or
So
not P.
yeah, I can just do a V, right?
Yeah. What's that?
Just a V?
Yeah, just a V, normal V. But I
Is
don't
that okay?
see it. Yeah, now I see it. Okay, yeah. Yeah, so what will be the truth values of that column?
So uh, so this is an inclusive disjunction we have. So if one of them is true, then it's true. So it's both true, true.
Yeah, exactly. Now, you'll see a fundamental difference between the first table and the second table. What's that?
Fundamental difference is that we just have a different operator here.
Oh, that's
So
yeah, but like with respect to the truth values?
so they're both in the first table. They're both false.
Yeah,
In the second table, they're both true.
right. So, the first one is the example of a contradiction. So, P and not P is like the textbook definition of a contradiction. A contradiction is a conjunction of a proposition and its negation. And the second one is the textbook definition of a tautology. A tautology is a disjunction of a proposition and its negation.
Okay.
Okay. And what's interesting is when you have a contradiction, all the rows of the truth table will be false. And when you have a tautology, all the rows of the truth table will be true. So that's how you like that's the definition of a contradiction. So like that's why whenever you have some like this is kind of reflective of like the law of non-contradiction. Like a contradiction by definition is when when all the rows of the truth table are false. So that would be a contradiction.
So
Yeah.
so yeah, just because you said a lot there. So if I just can make some notes
Yeah, yeah,
in the
sure.
document, I'll say the first one was a contradiction,
Yes.
and then the second was a tautology.
Yeah.
Is that how you spell it?
Yeah, that's right. Yeah.
Okay, and so what does a tautology mean exactly?
A tautology is when like all the rows of the truth table are true. Like the proposition which has all the rows to be true is a tautology.
All the rows of.
And contradiction is is a proposition where all the rows of the truth table are false.
Oh,
So the previous example, the one before the contradiction, can you show me that?
that's an example of a tautology then.
Exactly.
Okay.
Yeah. Now, can you think of some proposition which is a contradiction? Yeah, this you can take this as homework. Think of a proposition which is a contradiction, but it should not be like a simple form. Like I'm asking you for a contradiction, but like a complex formula. Yeah, a complex, a compound proposition. Compound proposition. Um, yeah, like a compound proposition that is a contradiction. Yeah, as an example of a contradiction. Yeah.
Okay, so people can also try this if they want.
Yep. Okay. Uh yeah, I guess we can move to the stuff that we were doing. We were going to start today.
So
Uh
you also sent me some converting natural language into no converting text into no converting operators and variables and operators into text. You sent me some examples. Do you want to have a look at that as well before we move on?
uh we can, but that'll exceed like the time we have like for today.
Okay,
We can
well,
we can
whatever
do
you
that
feel
next time, I guess.
better. Okay, cool.
Yeah, yeah, yeah. Because I want to get into the syntax before we get it. Like we can do the or what we can do is we can do the syntax next time and we can do the examples this time. What do you think?
I guess that's the whatever you
Yeah, you know what?
prefer learning.
Let's do the examples today, and we'll do a couple more examples, and then the syntax we can do next week, I guess.
Okay,
Yeah.
so then I'll show you what I what I did for the examples you sent me.
Okay. Yeah.
So yeah, I didn't spend too much time doing it, so there might be mistakes as
Yeah.
well.
Yeah. That's fine. That's
So
fine.
have a look. So this was the one you sent me, five questions. So just as a recap for people, this symbol represents an implication. The
Mhm.
yeah, and the dot can also be represented. Well, it represents an
Yep.
and then the tilde represents a not.
Yep.
Okay, and then here we have the disjunction.
Right.
All right, so I guess for the first one,
Mhm.
we have C. Willa teaches in the middle school.
Okay. Let's go step by step. So, what's the main operator of this proposition?
It's the conditional.
Yeah. Okay.
Seems to me.
So we have some antecedent and we have some consequent, right? So what would be the antecedent?
The antecedent would be the C.
Mm-hmm.
So Willa teaches in the middle school because the antecedent is what comes before the conditional,
Right.
and then the consequent is what we have here.
Yeah.
So here either side of the disjunction we have a disjunct,
Yeah.
and it's sort of a compound
Yeah.
proposition.
It's a compound proposition. The consequent is a compound proposition. So what's the consequent that you've written?
So I wrote, if Willa teaches in the middle school, then Willa teaches both English and history.
Mm. What do you think?
Well, I mean, I got someone just knocking on the door. Just
Yeah. Yeah. Sure.
can you
Sure.
hold it for a few seconds?
Yeah. 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 Sure. Sure.
Yeah, so I'm back.
Okay. Cool. Yeah.
So we can attack the question. So
Mm-hmm.
so yeah, C, Willa teaches in the middle school.
Mm-hmm.
So if if Willa teaches in the middle school,
Mm-hmm.
then I guess after that we have the the conditional.
No, with the
So
disjunction.
well, so on the right hand side of the C, that's a
Consequent.
conditional, right? Con- I mean, I'm talking about the symbol, so the operator.
Oh, yeah, 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 yeah. Okay, yeah. It's a conditional.
So would it be correct to then write then?
Okay.
So if Willa teaches in the middle school, then,
Mm-hmm.
and then Willa, and then, so because B is Willa teaches history,
Mm-hmm.
and then A, Willa teaches English, so then Willa teaches both English and history.
No, that doesn't follow.
Oh, okay, now we have a, sorry, we have a disjunction, so it's Willa teaches English or history.
Yeah.
Yeah, it's just, I need to get used to the symbols.
Yeah, that's fine, that's fine.
In my head, yeah, for some reason I was seeing it as this conjunction.
Yeah, yeah,
Yeah,
that's
but
fine.
the dot is the conjunction, which I explained
Yeah.
earlier on.
Yep.
So then, Willa teaches English,
Mm-hmm.
and and then the tilde is a negation.
Mm-hmm.
So Willa does not teach history. So Willa
Yeah.
teaches English, and Willa does not teach history.
Right.
And then number 3 is same again, back to Willa teaching English. So we also have a conditional, so we have
Mm-hmm.
the antecedent on the left,
Mm-hmm.
Willa teaches English, and then on the right, we have two variables inside there, connected in the consequent by a conjunction, and it's Jabir teaches English and Ahmed teaches English. So it's if Willa teaches English, then Javier teaches English and Ahmed teaches English.
Yeah. Yeah, that's fine.
And then after this we have another tilde, so it's a negation of D. So Willa has not got a master's disease, a master's degree,
Mm-hmm.
and so it's if Willa does not have a master's degree, then Willa does not. So on the consequent, we have the whole thing, the whole compound proposition being negated, and this is an or, so I'll need to correct this one as well. So yeah, we have an inclusive disjunction between the disjuncts. So it's an or. So
Yeah.
it's if Willa does not have a master's degree, then Willa does not teach English, or I guess you can say, or Willa does not teach history.
Yeah, so what you can do for this is like when you write negations, right? Like for compound propositions, you could say it is not the case that, and then represent the proposition. So it is not the case that Willa teaches English, or Willa teaches history. I mean, I'm not saying what you said is wrong, but yeah.
Okay, is this what you meant?
So it is not
Uh,
the case that Villa teaches. So you got to remove the Villa does not teach.
if Willa does not have the master's degree, then it's not the case that Willa teaches English, right?
Yep.
Uh, uh, is that right?
Yeah.
Okay, and then finally number 5, on the antecedent, we've got a compound proposition. This time, I think I got the right
Antecedent.
or operator. Yeah. This time, I think I saw the disjunction as correct because I put in an or between the yeah.
Yeah, but you missed the
two.
negation.
But yeah. So then if
It is.
IVA, so yeah, the tilde represents a negation. So then I can write it.
If it is not the case that.
Oh yeah, if it is not the case that IVA teaches English or Ahmed teaches English, and then after here we have the conditional, then Willa teaches history.
Yep, exactly. So this was turning symbols into natural language, but let's try something more difficult, which is to turn natural language into symbols. Let me pull up the examples from the book. Oh, these are quite big. Yeah, one sec.
I think it's good that I had a few mistakes in there just so people can also try and understand where I went wrong.
Yeah, that's right. So I've sent you the next set of questions on Discord. So you can just paste that in your document as well so that people can check that.
Can you see it?
Yeah.
So then we can do question 16. So, I guess I can go straight into it and then you can see how I do it, right?
Sure, yeah.
Well, I'll open my notepad because I've got all the symbols stored there from last time. Do you still see my screen or do you see me moving about?
I see your Word document.
Okay.
Yeah.
I've got a notepad open. That's okay, people don't really need to see that.
Yeah. You can use the symbols that are on your keyboard. You don't have to use the...
okay, cool.
Yeah, you can just use, for implications, you can use a dash and a greater.
Arrow.
Yeah.
Alright, so we have an F. So then... Okay, so... then I guess open a bracket. Then len. Something like this.
Yeah, put a space between the W and the... Yeah.
So after this, should I is this a new line for the next
yeah,
one?
you can you can put like a 16 and then a bullet point or like a sub 16, like you can just indent it with like an ABCD or something like that.
Or I can just, I guess, do a
Yeah,
point.
and
right?
you can do like P1, just use numbers instead of dots.
You think numbers will be better, right?
Yeah. So that's the first proposition or the first premise. So each of these are arguments, by the way.
Okay.
Always separate propositions and operators by a space. Yeah. Looks cleaner.
Cool. Is that alright for the next one?
Yeah. Okay. No, you can just do like a tab, press tab, space, like a slash. Yeah, and then you can
And
write.
then like this,
Yeah, put a
right?
space if you want. Yeah.
Always a space, yeah.
Yeah.
Right, so 17.
Yeah, you know the drill.
I'll just do it, and then if there's any mistakes, you can correct me, right?
Mm-hmm.
Cool. So here we have a conditional.
Yes.
So I need to make sure I get it the right way around. Yeah, we said sun. Uh, Let me just think a few seconds. Yeah, I'll write it out first how I'm thinking, and then I just. Yeah,
Mm-hmm.
let me see. And this one is tricky.
Mm.
So yeah, I just need a few seconds to think. So I'm a bit. Only if. So is this correct?
No.
No. So could you explain how to work this out?
So only
So
if when you use only if, what you do is the thing that follow. So it's basically like um the like the thing the proposition that comes after only if is um
sufficient or the necessary?
one sec. Wait, wait. Maddie is a naturalist only if. So only if just yeah, you're right. Yeah, this is fine.
Is this one correct?
Yeah,
What I
that's
did?
fine. Yeah, that's fine. Yeah.
Um, yeah, it's kind of difficult. The
Yeah, like
conditional
think about
is
like only when. So I will go to the party only when you go to the party. When I say that, I just mean if you go to the party, then I will go to the party.
yeah.
So think of that in this context.
So so
Only
if
if.
if right is not a non-logicist, then that means that Maddie will not be a naturalist,
Mm-hmm.
and that's what this conditional is doing there.
Yeah.
So if the truth value that right is neologicist, if that's false,
Mm-hmm.
then
Then
it
Maddie is
cannot.
a naturalist cannot be true.
Yeah, because then that proposition will have a false value,
Yeah.
right? Because the second one needs to be true.
Yeah.
But yeah, I'm probably going to make mistakes of the one going down the line because it's kind of difficult, and my brain needs to like
Yeah,
get
that's
a
fine.
few examples.
Yeah.
Um, cool. It's not clicking the new line. Okay, so
Mm-hmm.
So something like this.
Yep.
Hence, can you still hear me?
Yeah, I can hear you. Hello?
So the hence is a conclusion, right?
Yeah, that's the conclusion.
So it's hence, and then
Yeah, that's right.
inside we have a compound proposition.
Yep, that's right.
So you're okay with what I did?
Yeah, that's fine. Completely
Alright.
fine. The next one.
So this one is a biconditional.
Yep.
Then, so here we have a negation. Bruno is not a nominalist.
Yep.
So I add somewhere I had the tilde.
It's above the tab. Yep.
Oh, I have a Mac, so it's a little bit different.
Oh, damn. Okay.
Yeah, wait, I found it. Oh, wait. Is this Maddie is a naturalist unless Leng is an instrumentalist? Then the unless. That's something. Yeah, I'm a little bit unsure about. Could I do Maddie is Maddie is a naturalist, and then Leng is not an instrumentist.
No, don't change the propositions. Like you negated one of the propositions, right?
Yeah, so
Yeah, don't do
I
that.
cannot do that. Then I guess I need to do a conditional somewhere.
No, there's no conditional.
So what does the unless do there?
Yeah, so what do you think? Like, so it's not a conditional, so it's definitely not a biconditional. So what are we left with?
If it's not a disjunction or a conjunction.
So which one do you think is it a disjunction or is it a conjunction? Like think
So
just read the sentence and try to like think what it means. Like, Maddie is a naturalist. Just think of it in another context. Like, I will go to the party unless you go to the party.
So for me, it seems like an if sort of. So if Maddie's a naturalist as long as so when Leng is not an instrumentist, then Maddie is a naturalist.
Say that again.
So for me, in every case where Leng is not an instrumentalist, then Maddie would be a naturalist. But yeah, as you said, I cannot use a negation.
Yeah. So what you're yeah, but so so here unless just means like a disjunction.
So, or okay, so yeah, that sort of makes sense. Yeah, so you either have one or the other. Okay.
So you can have like so you can have something like I won't go to the party unless you go to the party. Right? So that'll be like not P or Q, and that's basically like an implication. So what you were interpreting as an implication, it like an implication just is like you can replace an implication with a disjunction.
Seems to be exclusive disjunction.
You don't have to worry about that for now. Just use inclusive for now.
Yeah.
Yeah.
Uh, for me, when I hear the word unless, it makes it seem like it's one or the other.
Yeah, I know.
Lem being
In real life, you don't have to go through this turmoil because you can just ask the person, the
mm.
interlocutor, what operator they're using.
So yeah, moving on to the next one, we have the acronym SUN. So
Mm-hmm.
so if Leng is a sufficient condition, then that means that we have it, the L on the left hand side. So
Yes.
and then for F field being so I put N there, but it's actually F.
Yeah.
And then so right is a neologicist, yet bueno is a nominalist. It seems like it could be a conjunction.
Yeah.
And then the last one, no, we actually have a conclusion there.
Mm-hmm.
So therefore F.
Yeah, just put a space, yeah.
Oh yeah, forgot about the space.
Yeah. Yeah, that's
Good
fine.
good habits.
Yeah, good habits. Like clean looking presentation.
Yeah.
Do you wanna do couple more with the same? I'll give you like couple more but with a different proposition set.
Yeah.
And then we can end this session.
Yeah.
One sec,
Sounds
I've
good.
sent to you the yeah. Send it to your Discord. Oh, you got it. Great.
Yeah. So 21. Oh.
By the way, these are from the Russell Marcus book. So
Okay.
there are a lot. There are quite a few. There are like 50 or so or 45 examples. So when you want some
Right.
more extra practice, you can try doing those.
Yeah, I'll link the book in the description of
Yeah.
the videos so people can find it as well and try.
Yeah. Yeah.
But it's good, yeah, I guess it can maybe before going to sleep it puts you to sleep.
If coffee keeps you awake, prop logic will put you to sleep. That was a conditional. Oh, no, no, no. Simple mistake. No, 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 no. What's the propositional variable for Harden? Sorry, for Hurst House.
Um,
And what's the propositional variable for?
I just assumed it was a H.
Oh, fix the first one as well.
Okay, yeah, I wasn't actually looking at the variables.
Yeah.
I just assumed if Harden is utilitarian that it would be a H. But
Yeah, yeah, yeah. No, no. You
this
need
one's
to.
not.
Yeah.
This one's not that initiative. Well,
Intuitive.
intuitive. Yeah, that's the word.
It is actually like the U stands for utilitarian. V stands
Okay.
for virtue ethicist. So
I know. I had Yeah, I had the R correct there.
Yeah.
So rule is again only if Hurst is not over.
There is no
Is that one
H.
better? Oh, yeah, you.
No.
Oh, ah, 1 minute. Okay, yeah, so, because, yeah, Hardin comes up
Yeah.
2 times. Well, that not Hardin, but
First
something
house.
with, yeah, difficult names. So, yeah, it's important to read carefully, I guess.
Yes. You don't need to put a space between the negation and the, because that's one proposition, right?
Hmm.
Yeah.
So consequently, Anscombe defends the doctrine of double effect if Hurst house
Oh, you
is.
missed one proposition.
Oh, yeah. Hardin is a utilitarian. So this one I have a U,
Mm-hmm.
and then consequently Anscombe defends the doctrine of double effect if Hurst house is a virtual ethicist. This one is pretty difficult. So if
By the way, that's a conclusion. So,
conditional, uh, yeah, this is a conclusion. So I put the slash,
mm-hmm. Space.
and then it seems like it's a condition.
Yeah, it is a conditional. A space after the slash. Yeah.
Like this. Consequently, let's see if I got quick letters.
Yeah, that's right.
First house, then. Alright. Okay. I need a space.
No, no, no. What's going on?
Hardin is a
You inverted
utilitarian.
the conditional.
Say again?
So when it says only if, it's the same order. When it only says if, that's when you flip the order.
Okay, so what I have here on this side, it needs to be on the other
So the
side.
antecedent is actually the consequent.
I
Right.
need some time, I think, to just, yeah, understand that.
One sec. So when you start the stream, there should be an option for better text readability. Can you change to that? Oh, yeah, that's fine.
Well, where can I change this option?
Cool.
Where can I change the option if you cannot read it? Because I was assuming the whole time that you can see what I'm writing. Can you still hear me?
Just one sec. I think this thing cut out. My headphones cut out. You can carry on.
No, I was saying, how can I change the settings to make it better?
Yeah, can you say something? Hello?
Yes. So 1 minute, I'll share my screen again, and I'll see if I have better text readability options. But last time I didn't have this. I guess just let me know if you can't see it well. Yeah, I've got resolution 720 that we'll have to do. Yeah, can you? Okay, you still there? So unless we've got another disjunction there, and we've got a negation, the Hearst house is not negative v unless so a v, right? No, no, does not. Hardin is utilitarian, then hence. Okay. Yes, it's going to take some time. The conditionals are pretty tough. I just need to spend some time visualizing it in my head. I know that was pretty useful. So yeah, I guess we can stop the recording there. Okay, was this related to syntax, what we were doing just now, or not at all? No. Okay, okay, yeah, cool. All right then, so yeah, next time we can definitely attack that. All right, So have a nice week, guys, and see you soon.